All right, good morning, everybody. The topic of today's lecture is inheritance. So we've talked about a few different relationships between classes. Right, so we talked about dependency, which is the weakest relationship you can have between two classes. And we've talked about the various forms of association, right? So association, aggregation, and composition, right? And so the strength of the relationship increases in that order, right? From dependency to composition. Inheritance is the strongest form is the strongest type of relationship that you can have between two classes in Java. Right? So here's a quote from the Java tutorial. So inheritance is a relationship between two classes where one class is derived from another class. And so the idea behind inheritance is powerful. If you want to make a new class, and there's already a class that does what you want it to do, then you can inherit from that existing class. And when you do so, you get all of the capabilities of the existing class without having to write your code, any extra code yourself. Right? And that also means that if you inherit from a well-tested class, then you have to write less code to test and debug your new code. Right? So it's one of the ideas, one of the reasons for using inheritance is for code reuse, right? Or for efficient code reuse. Right? So inheritance in Java, along with interfaces, forms the fourth component of the object model. Right? So this is what's called hierarchy in Java. Or this is one of the ways that you can implement a hierarchy of classes in Java. Right? So both both interfaces and inheritance can be used to implement a hierarchy of related interfaces or classes. Right? So this is a picture. This is a picture of what inheritance in Java sort of looks like. So in Java, there's what's called the class JavaLang object. Right? So in Java, this is the class that sits at the top of the object hierarchy. Right? There is no class above object in Java. Right? What this picture is trying to show you is that from object, you can have classes that inherit from object. Right? So all of these classes here inherit from object. This inherits from object. Right? So all of the classes in this top row, they directly inherit from object. Right? So this picture also shows you an example of what the word hierarchy means. Right? You can create what's called a hierarchy or a hierarchy of classes, right? Where you stack, in a picture, you've got one class that's on top of a bunch of classes, right? And then you have a class that's underneath another class, right? And a class that's underneath another class. So what this picture is trying to show you is this idea of inheritance. Right? So this class here directly inherits from object here, right? This class here inherits from the class above it. Right? Now, in doing so, right, this class also inherits everything that's in object. So we have, there's a bunch of lingo that you need to know, or a bunch of jargon that you need to understand or be familiar with when you talk about or when you study inheritance. The problem with inheritance is that people use a lot of different words to mean the same thing. So there's the notion of what's called a subclass. Right? So in the picture here, right, X or Y is the subclass to X. Right? Now people also use the term derived class, extended class in Java, and child class. So these all mean the same thing. These are all classes that are derived from another class. Right? And then there's the superclass, or base class, or parent class. Right? And so that's the class from which a subclass is derived. Right? So X is the superclass, Y is the subclass. Right? An example in Java would be object, right? is the superclass, and string is the subclass of object. Right? Every class that we've made so far in the course is also a subclass of object. Right? Even though we didn't explicitly say so ourselves. When you talk about inheritance in object-oriented programming languages, often you hear about this parent-child relationship. Right? So the analogy is you are descended from your parents. Right? Your parents are descended from their grandparents, and so on and so on and so forth. Right? So you'll often see that Y is called the child of X. In the UML diagram, so these are actually UML class diagrams. In the UML class diagram, you illustrate an inheritance relationship by drawing an open arrow, so triangle, and then a line, from the subclass to the parent class, or from the subclass to the superclass. So in this picture here, it says that string is a subclass of object. Right, now in inheritance, the relationship is strictly one way. Right, so string inherits from object. So in other words, it gets all of the public methods that are in object. If object has any fields, then technically string inherits those fields. Right? So all the capabilities that object has, string inherits. Right? But the opposite's not true. Right? So in other words, object does not have any of the capabilities that string has. Right? Furthermore, object has no idea that the string class even exists. Right? So the child class knows about the existence of the parent class, right? But the parent class does not know about the existence of the child class. Right? So it's strictly a one-way relationship, right? Which kind of breaks this parent-child analogy that's often used, right? Because the relationship is strictly one way. So this notion of hierarchy means that you can have a class that is that extends a class, that extends a class, that extends a class, and so on. In Java, that chain of inheritance has to come back to object, right? There's no, that's the way the Java language works, right? Other object-oriented programming languages don't necessarily work this way, right? So Java is a bit unusual in that it actually has a root class in its object hierarchy, in its inheritance hierarchy. So we say that a class is descended from all of the classes in the inheritance chain going back to object, right? So A is descended from Z, right? A is also descended from Y, and A is also descended from object, right? You can use other terminology as well, right? So you can say that A so object is a superclass of A, right? But it's not a direct superclass of A, right? So Z is the direct superclass of A. Right, so you can also use that kind of terminology as well to describe the relationship. Anything above A, so any class that A is descended from is called an ancestor of A. Right, so object X and Z, those are all ancestors of A. All right, so why do you want to use inheritance? So a subclass inherits all of the non-private stuff, so the members, from its superclass, right? Now the members of a class do not include the constructors, right? So subclasses do not inherit constructors from their superclass, right? But they inherit all of the all of the non-private, everything else that's non-private, the subclass inherits, right? Excluding the constructors. So if you have if you want to implement a class that's supposed to do something, and there's another class that already does what you want it to do, or does most of what you want it to do, you can use inheritance to derive your new class from the existing class. Right? So what does that mean? Your new class gets direct access to all of the public and protected fields and methods without having to redeclare or re-implement them. Right? And so that's very powerful, right? So you can get all of the benefits of another class without having to write a single line of code. Right? So, for example, if you make a class in Java, it automatically inherits from object. Right? So what's the implication of that? You can automatically use toString hashcode and equals on your new class without having to write an extra line of code. Right? It automatically inherits those features from the class object. Now, what else can you do? So it's probably the case that the class that you inherit from does not do everything you need it to do. So you're allowed to add new fields and methods to your new class, right? To extend the functionality of your new class, right? And then, additionally, you can also redefine or override, right, any method that inherits from a superclass, right? So when we override equals in our point2 class, for example, right, we replace the definition of the equals method that we inherited from object. Right? And similarly, you've seen that we can add a whole bunch of other methods as well, right, to the point2 class. Right? So we can add methods that change, to get or set the coordinates of the point, and so on and so on and so forth. Oops, sorry, just a second. Okay, so inheritance is the strongest type of relationship that you can have between a class, between two classes, right? And inheritance models the, or is supposed to model the is-a relationship between classes, right? So a point2 object is a big O object, right? A string object is a big O object, right? What other examples are there? It turns out an array list is an example. An array list is an abstract list in Java. Right? So it turns out there's a hidden class that you don't know about, or you probably don't know about, in the list hierarchy. Okay, now when we say is-a, we actually mean something very specific in object-oriented programming. So is-a is short for, is substitutable for any of its ancestor classes. Right? And so what does that mean? So for example, a string object is substitutable for a big O object. And what does that mean? It means that a string object can do anything that a big O object can do. Right? If you have a method that takes in a big O object as one of its arguments, then you can pass a string object to that method. Right? So that's what substitutability means. Right? Anywhere you need one of the parent class instances, you can pass in an instance of the child class. Right. So in Java, as I mentioned before, object is unique, right? It's also, I don't know of any other programming language that does it this way. So big O object is unique in that it's the only class in Java that has no superclass, right? And furthermore, that means it's the class from which all other classes are descended from in Java, right? If you don't, when you create a new class and you don't explicitly say what the superclass is, then the compiler automatically assumes that object is the superclass, right? That's why we haven't had to say anything special. We haven't had to mention the class object in any of our classes that we've made so far. Okay, so in Java, a superclass can have an arbitrary number of subclasses, right? So there's no limit on the number of subclasses that a superclass can have. Right, so here the class X has 3 direct subclasses, right? But the opposite's not true. So in Java, a subclass has exactly 1 direct superclass, right? So in other words, Y, the only direct superclass of Y is X, right? And there's no way in Java to have more than 1 direct superclass, right? So Java implements what's called single inheritance. Right. Other languages like C++ implement what's called multiple inheritance. So in multiple inheritance, a subclass can have more than 1 superclass. So the reason Java implements single inheritance is to avoid a problem that occurs in languages that allow for multiple inheritance. Right. So this is not Java, the picture I'm showing you here. This is just a generic UML diagram of some language that supports inheritance. Right? So here we've got this class X. Right? It has 2 direct subclasses, Y and W. Right? In a language that supports multiple inheritance, you can have a class Z that has 2 or more direct superclasses. Right? So here Z has a superclass Y and a superclass W. Right? Now you can't do this in Java. This picture here is showing you, it's got this funny name. It's called the deadly diamond of death. If you actually Google for that phrase, you will find a Wikipedia page for it. So it is a real thing. Right? And so the problem in languages that support multiple inheritance is it complicates the relationship between your classes. All right, so suppose X defines a public method called f, right? So in other words, you can make an X object and write little x.f. Right? Now, when you, in inheritance, right, Y and W, right, they both inherit X's method called f. Right? Furthermore, they can change how f behaves. Right? So Y can override f, and W can override f. Right? Or they can choose not to override f. Right? Either way. In multiple inheritance, you now have the problem of if someone makes a Z object and writes Z.f, which version of f do they get? Do they get Y's version? Do they get W's version, or do they get X's version of the method? Right? So all of the languages that support multiple inheritance have different ways of dealing with this problem. Java decided to not deal with this problem and disallowed multiple inheritance. Right? So that's one of the reasons why Java only supports single inheritance. All right, any questions so far about inheritance? Okay, moving on. So this concept of is-a or is substitutable for, this is probably the central concept that you need to wrap your head around when you're talking about inheritance, right? Everything else is mechanics, right? So implementing inheritance is just strict, it's just pure syntax, right? But this notion of substitutability, this is the one that this is the concept that's actually important, right? So substitutability means you can use a derived class object in place of an ancestor class object. Right? So for example, if you have a method with one parameter of type object, right? So here I've got a static method called SumMethod, right? Its parameter is of type big O object, right? Now what does this mean? So remember, object is the root or the uppermost class in Java's class hierarchy. So that means you can pass any object to this method, right? Not just any big O object, but literally any object, right? So I can make a string, right? And then I can call some method and pass in the string, right? And this, whatever this method does, it should do, right? So this method works, it compiles, and it should run, right? I can make a hash set, right? And pass in t to that method, and the method runs. I can make a point, right? Pass it into the method. Oh, wait, that's supposed to be a p, sorry. Right there, that's a p, right? Pass in that point to that method, and that method runs, right? So string is substitutable for object, right? Hash set is substitutable for object. Point to is substitutable for object, right? And that's all because of this is-a relationship that we have in inheritance. Right? Okay, so when programmers find out about inheritance, they tend to use it everywhere, which is actually a big mistake. The modern recommendation for using inheritance is to avoid it if you can. But there are instances where it's very useful, right? So if you don't need it, don't use it, right? Even though it's very tempting to want to use it. Okay? So is-a, or is substitutable for, right, has nothing to do with the real world, right? This is the other thing that you have to wrap your head around, right? When you're programming is not the same as the real world, right? So concepts that are true in the real world are not necessarily true in your computer program, right? Is-a, or is substitutable for, has everything to do, right? The only thing that is substitutable means, or is relevant to, is how you've modeled your inheritance hierarchy, right? So the classic example, right? This is the standard example that's always used to teach what not to do or when not to use inheritance, right? Is a circle an ellipse or not, right? So that's the classic example, right? So in other words, this is the question, right? So if I want to implement a hierarchy of classes, right, for shapes, right, you might implement an ellipse class. Right? And then you might say, well, hey, mathematically a circle is an ellipse, so I should have my circle class inherit from my ellipse class. Right? Now the question is this the right thing to do? And the answer is maybe. It's not yes, it's not no. Right? So it's maybe. Okay, so mathematically a circle is a kind of ellipse. Right? So that's a fact. Right? What you have to remember though is that this is a computer program, it's not mathematics. So if your ellipse class, right, or if an ellipse object can do something that a circle object can't, right, then circle is an ellipse is false, right, for the purposes of inheritance. Right? So if ellipse can do something that a circle cannot do, then you should not use inheritance to model you should not use inheritance to model the relationship between circle and ellipse. Right? Why? Because inheritance implies substitutability, right? If you implement this hierarchy like this, you're saying anywhere I need an ellipse, I can pass in a circle object, right? But you can see the problem right here, right? Right. So if there's some method in the circle class, right, that has a contract that says something very specific, right, and the ellipse class doesn't satisfy that contract, right, then ellipse is no longer substitutable for circle. Right? So if circle can't do something that an ellipse can do, then you cannot safely substitute a circle instance for an ellipse instance. Right? Now notice that word safely. This doesn't mean that you can't do this, right? So you can write a program that incorrectly uses inheritance, and it might run. It just might not do what you want it to do. Right? So there's nothing in the language that actually checks for substitutability. Right? Which means the responsibility is on the programmer to make sure that substitutability is supported. So here's an example of a method in Ellipse. Okay? So in Ellipse, we've got this method called setSize, right? So imagine that you're writing a program that lets you draw stuff, right? So you want to draw circles, ellipses, squares, rectangles, so on and so forth, right? So if you're implementing a drawing program, you probably want to change the size of the shapes that you draw, right? So you say that in Ellipse, you've got this setSize method, right? SetSize changes the width and height of the ellipse to the specified positive width and positive height, right? So in other words, I'm not showing you the validation of the width and height, right? We're just going to have a precondition that the width and height are both positive, right? So this lets you change the size of your ellipse, right? And that's what the method says it does, right? So it promises to change the height and width to the specified height and width, right? You look at the implementation and it does exactly what you'd expect it to do, right? Now, the problem is circle and ellipse? Wait, do I have this relationship? Yes, is circle and ellipse, okay. Right, so now, mathematically, a circle is an ellipse, right? But if ellipse can do something that circle can't, then you have a problem, right? Because circle is an ellipse is false for the purposes of inheritance, right? So, whoops, I just repeated myself, sorry. The contract for setSize in ellipse, right, says that the width and height of the shape will be changed to the specified width and height. Right, now what's the problem if you have circle inherit from ellipse? Right? Circle is also going to inherit this method. Right? So it inherits the setSize method. Right? It doesn't just inherit the method though. It inherits the contract. Right? So in other words, the circle method called setSize also changes the width and height of the circle to the specified width and height. And that's a problem because you can't change the width and height of a circle arbitrarily. Because if they're different, it's no longer a circle. Right? So if you call setSize with a circle object, there's no guarantee that the resulting shape is still a circle, which is probably a problem. Right? Right? So remember, circle, if you say that circle inherits from ellipse, it gets the setSize method. setSize says that it's going to change this height and width. Right? There's no weasel language in here that says it might not change the width, it might not change the height, right? It says it changes the width and height. Right? Okay, so that's a problem, right? If there is a setSize method in the ellipse class, right, then you almost certainly cannot safely implement circle as a subclass of ellipse, right? So what happens if there is no setSize method in ellipse, right? Well, if a circle can do everything an ellipse can do, then you're fine. Right? Then you can actually use inheritance. Right? So if there's no setSize method or any method that tries to make a circle not be a circle, right, then you're fine. You can go ahead and use inheritance if you want to. Right? Okay, any questions about that? All right. If you're reading the notebooks on inheritance, there's a lot more examples about what happens, right? So in the notebooks, there's actually programming examples of what happens when you incorrectly use inheritance. Okay. All right, so let's actually try to use inheritance to do something useful, right? We've been talking about stacks a fair bit. One way to so we've seen that one way to implement a stack is to use composition, right? So we have a stack. To hold the elements, we use a list, right? Pushing an element onto the stack adds an element to the end of the list. Popping an element from the stack removes the element from the end of the list, right? Furthermore, our stack implementation that uses a list never exposes the internal list, right? So there's no method that actually returns the list inside. So we're actually using composition when we implement that list, that stack, right? Okay, so a stack looks a lot like a list. We know that, right? So instead of using composition, why don't I just use inheritance? So why don't I say stack is a list, right? So why might I want to do this, right? Because I get its add and remove methods for free if I do this, right? Which is what I want, right? I want to be able to add to the end of a list, when I push an element onto the stack, I want to add to the end of the list, right? When I pop an element, I want to remove from the end of the list, right? So I can make a stack of integers by inheriting from array list integer. Right? So in other words, I can write this, right? So this is what inheritance looks like in Java. This is what a simple inheritance example looks like in Java, right? So we write public class, name of your class, right? So here I'm calling it bad stack because you shouldn't do this, right? If you want to use inheritance, you then use the keyword extends, right? So that's Java's keyword for indicating you want an inheritance relationship, right? And then you say the name of the class that you want to extend, right? So I want to extend array list integer, right? So this just says that a bad stack is a child class of array list integer, right? Now, if you do this, there's no need to have any fields in our stack class, right? I don't actually need a collection to store the elements of the stack because a stack is a list, right? That's what extends or inheritance means, right? Bad stack is a list, right? Which means it already has some field in it. We don't know what. Well, actually we do. We know it's an array, right? So it's got some fields that can store the elements of the stack, right? Because it got them from array list, right? You don't actually know what fields they are. It doesn't matter, right? All I need to do is use the methods that are in array list to implement the stack, right? So for example, to push an element onto the stack, right? I just call add, right? So I can just write this dot add value, right? There's no list object here, right? There's no list field here. Right? So in our original implementation, we had to write this dot field name dot add, right? But now a stack is a list, so I can just call the add method, right? So this add value, and that does exactly what we wanted to do, right? It adds that value to the end of the list, right? Because bad stack's a list. What about pop, right? So pop, of course, you should check if there are actually elements on this stack. Hang on. So for pop, we just want to remove an element from the stack, right? We want to remove the top element from the stack. Stack is a list, so I just want to remove the last element from the list. Right? So I simply call remove and the element that I want to remove, right? And then I return the removed element. I don't even have to check if the stack is empty. Right? Remember, if a stack's empty, you should throw an exception to indicate the stack's empty. Right? But remove will throw an exception if you pass in -1, right? Because this size will be 0, right? -1 will be, -1 is equal to -1, right? You're now passing in a negative index to remove, that'll throw an exception. So you don't even have to do the validation for yourself, right? The list itself will do the validation for you. It might throw the wrong exception, right? It's going to throw some sort of index out of bounds exception, but whatever, right? And that's it, you're done. Right? There's your stack class. Right? No fields, right? No methods except for push and pop. You get equals for free, right? You get hash code for free. You get toString for free, right? You don't have to override them. They're all there for you, right? So it looks great, right? And it actually works. Look, there's not even a constructor, right? You don't even need a constructor. You get the constructor for free if you don't implement the constructor, right? So I get the no argument constructor for free. Right? I can push some elements onto the stack. Everything works fine, right? I print out the stack, you get 0, 1, 2, right? Which is exactly what you want, right? I can pop the stack, right? When I pop the stack, I get the 2, which is great, right? Because the 2 is on the top of the stack. I pop it again, I get the 1. Again, great. Pop it again, I get a 0, right? Pop it again, you get an exception. The exception comes from the list class for free, right? Or from the array list class for free, right? So it looks amazing, right? You wrote 1, 2, 3, 4, 5, I guess 6 lines of code, and you have a fully functioning stack. Right? So that's the power of inheritance, right? Why is this a bad idea in this case, right? So remember what inheritance means, right? Inheritance means is-a, right? So when we wrote bad stack extends array list, we're saying a stack is a list, right? But that's not true, right? At least that's not true from a data structure's point of view, right? So from a data structure's point of view, a stack is not a list, right? A stack should only be able to push and pop elements at the top of the stack, right? But if you use inheritance, that means that anything a list can do, a stack can also do, right? Because you get all of the methods from the list class, or from the array list class. Right? What does that mean? I can get an element from the middle of the stack using the get method, right? You're not supposed to be able to do that with a stack, right? You're only supposed to be able to get the top element. I can change an element in the middle of the stack, right? Again, you're not supposed to be able to do that with a stack. You're only supposed to be able to push and pop the top element. You can remove any element from the stack, right? So just call the remove method in the list and you remove an element, right? Again, that's not the way stack's supposed to work, right? And you can iterate over elements of the stack as well. Now that last one actually might be useful, right? So you can actually write a for each loop on this stack class, on the bad stack class, and you can loop over all the elements in the stack. That one might genuinely be useful, right? But the other three, or 3 things there, right, you're not supposed to be able to do with a stack. And that's a problem from a data structure's point of view, right? In other words, if you use inheritance in this case, you can do stuff to the stack that you're not supposed to be able to do, right? So for example, I can push some elements onto the stack, and I can get the middle element, right? I can change the middle element. If you wanted to, you could remove the middle element, right? And all of those are things you're not supposed to be able to do, right? So in that example, that's an incorrect usage of inheritance, right? So inheritance should only be used when an is-a relationship actually exists, right? Now, stack's not a list, right? Therefore, you're not supposed to use inheritance to implement the stack, right? Now, if you do decide to use inheritance to implement the stack, right? So if you decide that your stack really is going to inherit from the list class, right? You shouldn't feel bad because even experts get this wrong, right? So if you look in the Java standard library, right, you will in fact find a stack class, right? So there is Java util.stack, right? This stack class does exactly what I told you not to do, right? It inherits from a class that's essentially a list, right? So it inherits from Java's old list class. It inherits from something called vector, which is the original list class in the Java language, right? And so what does that mean? If you use Java util.stack, you can add elements to the middle of the stack, you can take them out, you can remove stuff from anywhere, right? It's not really a stack, right? It has a push and pop method, but it has lots of other methods as well, right? So using inheritance incorrectly is something that actually happens with some frequency, right? Especially with older code. In well-designed modern code, this tends to happen less because people have learned over the years when you should and should not use inheritance, right? Okay, so how should you implement a stack? Well, the way that you should do it in this case is to use composition, which we already did, right? So instead of stack is a list, right, use stack has a list, right? It's almost as easy as using inheritance, right? So the implementation of stack using an array list, right, was pretty straightforward, right? You throw in a field that's an array list, and then you call add and remove on the array list, right? There's almost no difference. So the modern recommendation of inheritance is to use composition if you can, right? And to use inheritance only if you need to, right? All right. So what is a good example of inheritance, right? So it turns out teaching inheritance to new programmers is actually extremely difficult because all of this standard textbook or examples that you find on the internet, they're all terrible, right? They all do things like have something like a class called employee. and then they have a manager class that inherits from employee, right? Or they have a person class, and then they have like student inherit from person, and then grad student inherits from student, stuff like that, right? Those are all terrible examples of inheritance because you would never do those. You would never do such a thing in a real program, right? So it's actually hard to find an example of when you should use inheritance. The simplest example of when you might use inheritance is for this counter class, right? Now this counter class is absurdly simple, right? It's just something that counts, right? So why do you want to use inheritance for this counter class, right? Because you can make different kinds of counters, right? So using inheritance, I can implement different types of counters, right? So our counter class, right, starts counting from 0, goes up to integer max value, right? If you hit integer max value, it comes back around to 0, right? So in other words, it wraps around, right? But what if you wanted to change that behavior, right? So what if you wanted counters that don't wrap around, right? They do something else, right? There's our counter class, right? There's our existing counter class, right? Public class counter has got a value, constructor, value method, right? Advanced method, right? So we're really only concerned about this one method advance. Whoa, sorry. All right, so if you want some other behavior when the counter reaches its maximum value, right, then one way to do this is to extend the counter class, right? Because when I extend the counter class, I can override advance, right, to change how advance behaves when you hit the maximum value, right? Okay, so I want to change the way that advance behaves when it hits the maximum value, right? So in other words, I want to look at the value of the counter, and then instead of setting it to 0, I might want to do something else, right? I might want to throw an exception. I might want to stop counting so it doesn't count past integer max value and it just stops, right? Or something else, right? But whatever it is I need to do, I probably need to see the field this dot value, right? Now, if you look at the counter class, right, when we implemented it, we made the field private. Right? If you make a field private, that means it's only usable inside the counter class. Right? If I inherit from the counter class, that field value is not visible to the subclasses. Right? So subclasses cannot see the private features of the class that they inherit from. Right? Which could be a problem in this case because I probably want access to the value. Right? So our subclass has no way to modify the value of the counter, right? And if we're going to change the way that advance behaves, we need a way to change the value of the counter. Right? Now, this is a common problem when you try to extend a class that was not designed for inheritance, right? So when we made the counter class, we had no idea that inheritance even existed in the Java language, right? So we never created this class with inheritance in mind. So if I want to use counter class as a superclass, I have to do some surgery on the counter class. Right? So the first thing I have to do is I need to make that field visible to its subclasses. But I don't want to make it visible to every class. Right? I want it to be visible only to the subclasses, right? Or almost only to the subclasses. Right? So the keyword that you use to make fields or methods visible to their subclasses is protected. Right? So the protected access modifier allows subclasses to access a field or method directly by name. Right? So I'm going to change the counter class so that its value field is now protected. Right? Now any subclass of counter has access to that field. Right? Now when you do this, you should probably document the existence of the value class, right? So in other words, you should probably slap a java.doc comment here, right? Because the only way that people using the counter class are going to know that this field exists is if you document it, right? They may not have access to the source code of counter. So now you need to document this field, and when you generate the java.doc for the class, you have to generate the java.doc for the protected elements. Right? Because the purpose of the counter class now is to act as a superclass for other counters. Right? So that's what you say. That's what you're saying when you're designing a class for inheritance. Right? You're saying to everybody, hey, use this class to inherit from. Right? So now you have to document this field, and publish the documentation for this field, right? For the protected elements of your class. Everything else stays. Oh, I also have to do something else, right? So remember what inheritance means. It means your subclass is substitutable for the superclass, right? When a subclass inherits a method from its superclass, it also inherits the contract of its superclass method, right? Now, what does our superclass method say, right? So here's advance in the original counter class, right? It says it increments the counter by 1. If the method is called when the current value of the counter is integer max value, the value wraps around, right? If you want to change that behavior, you can't, right? Because the contract for the method says that the value wraps around to 0. Right? If I want to change how that behaves, right, I have to change the contract for the method as well. Right? So I should modify the contract of the advanced method to indicate that the subclasses might change how this method behaves. Right? So if this method is called when the current value of the counter is equal to integer max value, then the value of the counter is set to 0, but subclasses can override this behavior. Right? So when someone uses the counter class, they say, oh, hey, look, the value is going to wrap around to 0, right? Unless, right, they're actually using a subclass of counter, in which case something else might happen. Right? Now, without that line, right, without that change to the contract of the method, right, you can't safely override advance to do something else. Right? Now, the reason you can't do this is because someone can write code, right, using the superclass contract, using the superclass interface. Right? So in other words, someone can write a code that works with the counter. Right? So they write a method that takes in a counter object. They look at the advanced method and they say, oh, the counter is always going to wrap around to 0. So the code that they write, they're supposed to be allowed to assume that the counter will in fact wrap around to 0 when it goes past integer max value. Right? So they can write code that relies on the fact that the counter is going to wrap around to 0. Right? The problem is when you pass in a subclass object that doesn't do that, right, their code now breaks, right? Because your subclass is now going to change the way that the counter behaves when it hits max value. Right? So you have to modify the contract as well to indicate that subclasses might do something different. Right? So subclasses are supposed to be substitutable for their superclass. If you don't modify the contract for the advanced method in the counter class, there's no way for subclasses to safely change the behavior of advance and still be substitutable. Right? Now again, there's nothing in the language that stops someone from inheriting from counter, right, and then changing the way that advance behaves, right? Even if you change the Java, even if you don't change the Java doc. Right? So there's nothing in the language that prevents you from breaking inheritance, right? It's the responsibility of the programmer to make sure that their classes are substitutable for their superclasses. Right? Okay, once I've made those changes, I can now extend the counter class to implement different behavior when the counter reaches integer max value, right? And it's very simple. You just override advance, right? So if I want a counter to stop counting when it hits max value, it's easy to do, right? So you subclass counter, right? So I'm going to call the class StoppingCounter, right? Now remember what happens when you subclass another class or inherit from another class. You get all of the non-private stuff that's in the superclass, right? So I don't have a field here that represents the value of the stopping counter, right? The field that represents the value of the counter belongs to the superclass, right? So in other words, the storage for the value, it only exists in one place, right? Or it should only exist in one place. It exists in the superclass, right? The subclass is just going to reuse that field, right? So don't redeclare the value field here, right? So the stopping counter class has no fields of its own. The current value of the counter is stored in a field that belongs to the superclass, right? There's no need to add another field to store the value, right? Furthermore, if you do add another field to store the value, your class is probably going to break, right? There's going to be situations where the wrong thing probably happens, Right? Now, if you do decide that you need to add fields, that's fine. Go ahead and add new fields. Right? Keep in mind that inheritance is strictly a one-way relationship. Right? If you add fields to the subclass, the superclass can't see those new fields. Okay, so I want to initialize the counter so that its current value is 0. So I need some constructors, right? So subclasses do not inherit constructors from the superclass. Right? They have to implement their own constructors. Now the question is, what goes here, right? Because I have to set the value of the counter to 0. Right? So constructors of subclasses. The purpose of any constructor is to initialize the value of its fields. Right? That's the purpose of every constructor. Right? So the question is how can a constructor set the value of a field that belongs to the superclass? Right? So how do I set the value? How do I set the field called value in the superclass? Right? So we made value protected. So in fact, you are allowed to access it by name in the subclass. Right? So technically here you can you can write this value equals 0. And in this case, that would be fine. Right? So I'm allowed to access the fields of the superclass if the superclass made those fields protected. Right? But there's a better way to do this. Right? Your superclass has a constructor. Right? So the counter class has a constructor. That constructor, or one of those constructors, will set the value of the counter to 0. So why don't I call the superclass constructor instead? Right? Now, the advantage of doing it this way is that this works even if the superclass has fields that are private. Right? So if the fields in the superclass are private, I can't access them directly by name in the subclass. But I can still call the superclass constructor. Right? And the way you do that is with the keyword super. Right? So this is new now. Right? So in a constructor, on the first line of the constructor of a subclass, if you write the word super, you're calling a superclass constructor. So I'm calling one of the counter constructors when I write super here. Right? You need the round brackets because it's a constructor call. Right? There's no argument inside the round brackets. Right? So this is calling the counter class's no argument constructor. Right? The counter class's no argument constructor sets the value of the counter to 0. So that does exactly what I want it to do. I should stop there because the next part's there's a bunch of rules that I'm going to throw at you shortly. So I'll stop there and we'll finish this up on Friday. Any questions about today's lecture? All right, great. I guess we're all done then.